Okay, this is the second method that you folks have to learn. It's called the square root method. It's a little different from the factoring method. There will be no factoring here. First step, you need to try and get the square term by itself. So in this case, the x squared. We're going to divide both sides by 2. Okay, now you kind of did this before in a chapter test or a quiz in an earlier section. Some of you decided you're going to square root both sides, which works. You just did it wrong. We know this is x. Now, we're looking for all of the numbers that multiply out to 9. So 3 is supposed to have been the answer that you get, but there are actually 2 possible numbers that can be squared. A positive 3 and a negative 3. Those are your solutions. If you want, you can write it shorthand like this. Positive and negative 3. I'll accept either. Okay? But again, you're looking for all the possible values of x that if you square it, it gives you 9. So if you square root both sides, you get 3 and negative 3. And that's the solution that a lot of you missed, for those of you that did it with the square root method. Okay, here, you try. Get the square term by itself, and then you square root both sides. Ready? Okay, first step. Okay, we'll divide both sides by 2. That'll give us the square term. We square root both sides. All possible values. We can't square root the 10, so it's just positive and negative square root of 10. And that's it. 2 possible solutions. Let's try that one more time. Here, try this one on your paper. Ready? Okay. Divide by 3 on both sides. That'll get the square term by itself. And then you square root both sides. Is that okay? Oh yeah, we can have radical in the denominator. So, it's correct. We just have to multiply top and bottom by radical 3. That's your solution. Positive and negative radical 15 over 3. Let's make it more challenging. Okay, yes, this one is factorable, but we're going to solve using the square root method. Go ahead. Okay, let's try. We need to get the square term by itself. We'll add 100 first. That'll give us 4m squared equals 100. Now, you could square root here the way it is, because we can square root the 4. I wouldn't suggest that, though. I would try to get rid of the 4 as well. And now you square root both sides. Yeah, 5 and negative 5. And this, like I said, in a previous test or quiz when this was given, a lot of you went with this method and you would have forgotten the negative 5. Yeah, there are 2 possible answers that work. Okay, try another one. A little different. Okay, got it. The square term is already by itself. It's this x minus 3 squared. We are going to square root from here already. That'll give us x minus 3. On this side, we have 2 possible solutions, positive and negative 4. Now we just get x by itself. Three plus or minus 4. Now, you can't leave it like that because we can still actually evaluate each one. So, there are 2 possible solutions, 3 plus 4 and 3 minus 4. So, 7 and negative 1. These are the 2 solutions we're looking for. Yeah, you got to go as simple as you possibly can. This is correct here, but it's possible to go further. Okay, try this problem. The square term is already by itself, so we're going to square root both sides. X plus 3 equals positive and negative radical 10. Good. I think we did something like that in an earlier frame. Just get x by itself now. There. Two solutions. Okay, now, later on it may ask you to evaluate the radical 10, but for now, simplest radical form is fine. Okay, let's make this a little more challenging. Go ahead, see what you do with this one. Okay, so, first step, I kind of get the feeling that some of you tried to get the x squared term by itself. So you got rid of the 121, and you got rid of the 22x. The only problem with this is that now you have an x on both sides. Yeah, you have x on the left side and on the right. What is this? 48. And we can't solve when the variable shows up on both sides. What you should have done, and maybe I said you wouldn't need to do this, but you need to factor here. But we're not going to put it in standard form. If you look at this side right here, yes, it is factorable. And then you'll notice 11 and 11, plus and plus. That'll give us the 22 in the middle. So really, we had the x squared term already. It's just it wasn't in the correct format. Squared is equal to 169. Yeah. And then we go about doing it the same way we did the previous couple frames. We square root both sides. X plus 11 equals plus and minus 13. And then we just solve for x. Negative 11 plus or minus 13. So we have two possible solutions. Negative 11 plus 13 is 2. Negative 11 minus 13 is negative 24. If we had done it with the factoring method, we would have got 0 on one side, and then we would have just factored it. And I can tell you right now, it was factorable because we came out with nice answers like this. Yeah, but the square root method works just as well here. Let's try that one more time. Same idea. Ready? Okay, we are going to factor this side. We need a 49, so 7 and 7. Okay, so it factored nicely. It's actually x minus 7 squared. Okay, now we just solve. Square root both sides. X minus 7 equals positive and negative radical 3. Okay, x equals 7 plus or minus radical 3. And that's it. Yeah, so with this method, it may be necessary to factor, but they're giving it to you where it's going to factor into something nice where the two parentheses are going to be the same. When we get to the next section, it's not going to come out that nice. And that's why we need to know another method. So, go ahead. Try the problems. It is page 583. Numbers 3 to 36. Multiples of 3. We'll keep it short.